Alright guys, welcome to the channel. Today we're going to be going over BoostOS version 5, the newest release by Turbo V6, aka Brandon. Super cool guy. He's helped me with this OS. He's built the OS actually, but I've used it for a little while and he's kind of helped me troubleshoot a few things, and there's been a lot of requests for me to make a video on how to get this up and running and working. So today we're going to cover what all is needed, how to do it, and basically just about any info I think you will need. First off, we're going to go over to Google on whatever web browser you want to use. I'm using Chrome. We're going to type in Tuner Pro. It's going to pop this up here, tunerpro.net. We're going to click on it. It's going to take us into their page. Scroll on over to the downloads, Tuner Pro applications. Right here, you're going to download the latest version of Tuner Pro. You're going to download that, run the installer for it, install it onto your computer. Then you're going to be ready to use Tuner Pro. But we need a few other things before we get into Tuner Pro. We're going to go over to Patreon under Turbo V6. In this Patreon, June 9th, he posted this BoostOS version 5 and updated patch tool. Gives you an explanation here of everything that this BoostOS can do. Let you read that, and we're going to come on down here. He highlights in this 12587603. That is the OS number that you have to use BoostOS. You have to have this one. The others will not work. It has been designed around this OS. If you have a truck that has a different one in it, that is okay. We can put this OS in your truck as well. You're just going to have to change a few things in the bin itself to make it match your truck. We're going to scroll down here. He gives you a little bit of instructions here, a link to that Tuner Pro, PCM Hammer version 20. Version 19, version 21, they don't work. It has to be version 20. I believe version 21 doesn't recognize the OS or something like that. But version 20 is what we're going to need. He gives you a link here. You can also Google PCM Hammer V20 and find download links for it. But you're going to click that and you're going to install that. PCM Hammer version 20 is going to be used to write this file. I'm not really going to cover it very much in this video. This is the first video of this series. I'm going to do a two-part series. The second part is going to be how to write it, how to data log it, what kind of data you need to go over, etc., etc. So this is just some download links. We're going to scroll on down here. These are the three things we're going to need today for first and foremost. We're going to need this checksum plugin here. We're going to need the BoostOS patcher, and we're going to need this XDF file. Once you've downloaded all those, save them to an appropriate folder, downloads, documents, desktops, wherever you want to. I have a dedicated folder just for this video with a fresh file to kind of go over things. So we're going to go down here, open up the folder, and you'll see everything I have here. I have this bin file. This is just one I got offline. It is a 6.0 4L80 truck bin file that's bone stock. I'm just using it for just detailed purposes to go over today and kind of teach you guys how to work with this. So first thing we're going to do is we're going to open up this BoostOS Patcher 1.9. And when you open it, it'll come to this, or it may even give you a little blue screen that says your computer's been protected, blah, 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 blah. It's not a signed application. It's just a small one he's made. You can click the more info and click run anyways, and it'll bring you up to this. So you're going to want your tune file, or the file that you're going to be turning into BoostOS, this bin file right here. You're going to want this in the same folder that your BoostOS Patcher 1.9 is in. So when it pops up here, it wants you to enter an input file name. That is going to be our bin file, 12587603.bin. That's very important. You have to have the .bin. It will not work. If it's got a name in it, I suggest you name the first file that you're gonna make with this. You can rename it later. Name it something easy, because if it's got a capital, if it's got a number, if it's got an exclamation point, it has to be exactly how it reads right there. This is why I've made it just that number.bin for the ease of use on this video. We're gonna click enter, and it's gonna tell you that it matches, so you can use it. Gives you all these versions to upgrade to. Why would we not upgrade to the latest one? I don't know. That's up to you guys, but we're going to click version 5.2. Keep factory OS ID. You can use his custom OS ID that he used, which is kind of like his identifier for BoostOS to know it's BoostOS. I keep the factory OS ID, and the main reason I do this is because in my findings, the factory OS ID is needed to log short-term idle trim and long-term idle trim on your VCM scanner. It will not recognize these things if you have anything other than a factory OS ID, and I like to use those to dial in my IAC for a camshaft and other things. So we're going to keep this. The output file name is going to be what it creates, so we're just going to call it Boost in all caps .bin, because this is going to be our BoostOS. And then it says press any key to continue. When you click this, it disappears. Now we have our original file and we have our boost.bin. You want to name it something different so it does not get rid of or overwrite your original file. You always want to keep your original file. But now that we have this boost.bin, this is what we're going to be editing. This is our tune file per se. So we have this checksum. The first thing we're going to want to do, you've already installed Tuner Pro at this point. You're going to want to copy this checksum file, and you're going to want to go to Documents. And in Documents, once you have installed Tuner Pro, you will have this folder. It automatically installs it. You open it up. There's a plugins here. You're going to click on this. You're going to right click and you're going to paste your checksum file here before you open the application. Just go ahead, paste it here. If you've already opened Tuner Pro, you can close it out, paste this here, and then reopen it. But you want this pasted here first. Once that's done, you can go ahead, exit out of this, and we can open up Tuner Pro. So I'm going to open up Tuner Pro here. And you're going to see I've already been using this, so some of the stuff's set up. But we're going to click XDF, we're going to select XDF, and we're going to navigate to our folder where we had this at, where we've downloaded this new XDF file from his website or from Patreon. Click on this. That's going to select your XDF file. Next, we're going to select our bin file, which is the BoostOS, boost.bin, and it has pulled it up here. You can tell in the top left corner, boost.bin is pulled up. I click View By Parameter Category. You can click however you want to. You know, this way is very. I'm just not a big fan of the rest of the little views here, but to each their own. So parameter category is what we're going to view this in today. First things first, your fuel system, engine diagnostics, calibration, transmission calibration, vehicle system, speedometer. This is all the typical stuff. This has not been changed by BoostOS. All of this stuff is going to function for the most part as it would if you were using Tuner Pro to tune a stock computer file that had not been modified. All of this stuff here you're going to want to get from your original file, whichever one that you've had in your computer. So in my case, I have a 99 Silverado that has a P59 in it. I've swapped, but some of that stuff I had to get out of a P59 file. I got it from VCM scanner, HP Tuner's VCM scanner. I went in and kind of copied it, pasted it back in. It's a little bit tedious. It's a little bit of time. But if you do have a P59, you can go ahead and pull your factory bin file off of that, even if it's not the same OS ID as this one, and we can use this compare feature here. So I'm going to compare my tune file to this one. Let me go ahead and go to my tune file here. This is the one for my personal truck. We're going to select it, make sure it's got the check mark by it. So now we're comparing the two against each other. So the first thing, before I dive in, I just want to show you what that compare feature looks like here. I'm not using 2-bar, I use 4. So here's your 4-bar. You have absolute or you have the difference. So when it's absolute, you see here is your current file. And if you click this little button here, show compare bin data, that is what I'm comparing it to. I can copy and paste that whole table. I can copy pieces, bits and pieces if I wanted to, however I wanted to do it. If you click difference, it'll show you the difference between the two. Like this particular cell is 45 less than what I have in my other one, because this one's 0 and my other one is 45.18. But I just use absolute here. That way you can copy and paste if needed. Anyways, that is your compare feature. So now that we have gone over the basics of how to get this OS loaded up and how to compare files in here. Let's start going over the actual Boost OS. So the first thing we're going to scroll down to here, there's a few of these. None of these I'm going to touch on today, maybe a little bit. But so patches here is where you first start the Boost OS. He has a flex fuel patch here. He gives you the wire A, wire B, wire C, where to put them at to use flex fuel and to populate the tables to get flex fuel working. If you click on this, you click apply patch and click apply, that is going to enable flex fuel and tell this ECU that you have a flex fuel sensor hooked up, and it's going to use that where you can run E85 or pump gas. And you can verify this because if you click on it again, it still shows it's not patched, which isn't true. You can verify this by going to engine calibration, flex fuel option, it is checked, and then your data is put in here. All of this data is auto-populated for you. You're ready to go. So that's your flex fuel patch. Your next patch is the lean cruise. Some of the Australian vehicles got this lean cruise. It helps save fuel when you're going down the road, stuff like that. You can use that if you want to. I don't use that, but it's worth a try if you want to try it. So now we've gone over patches. Let's move into the Boost OS. This is where all of the magic is going to happen. We're going to open up this Boost OS folder here. The first one we're going to look at is your VE tables. So you have a 2-bar or a 4-bar VE table. We're going to click this here, and it gives you a number. 0 is factory tables. It's going to use all the factory fueling and spark tables if you click 0. 1 is your 2-bar VE table. If you want to use the 2-bar, you can use the 2-bar, and you would set that at 1. 2 is for the 4-bar VE table. So I would set it at 2 because I want to use the 4-bar VE table. We're going to save, and now we have selected which VE table we want to use. We go ahead and open up this VE table here. You're going to notice you've got your RPM axis at the top, your boost axis down the bottom, your map axis, I guess I should say. So this is your volumetric efficiency model that you're going to be working with here. The numbers are going to look like they would in an HP Tuner's 2-bar, 3-bar OS. Those numbers are all going to be the same. They're Gen 3 GM VE table numbers. You're going to want to populate this. It all starts out with zeros because you can't copy GM data and put it in here because the GM data is so tiny. It would only populate a quarter of this whole map. So you've got a very well thought out, very large VE map to work with. This makes the tuning a lot better. It's just all around a better setup here. So I'm going to go over here, and I'm just going to copy my other file into this just for purposes so it looks like we have something in there. Now I've pasted my other table in here. Well, I kind of screwed up. I didn't paste it all. My bad. Let's do this again. There we go. So now I have a VE table. And then I'm using a 4-bar. So that's your VE table setup. That's how you're going to be fueling this this new setup. That's pretty straightforward compared to HP Tuner's EFI Live. It's the same thing, just a little bit better, a little bit bigger map, better data there. So boost control. This is your next one. You've got a few options here. You've got your lean boost cut safety. This is for if your engine goes lean, it's going to cut the boost. So you've got your minimum map. So if it goes lean at 4 pounds of boost and you don't care, you can say, you know what, I just need it to be over 4 pounds of boost or over 135 kPa. If it's lean a little bit below that, it's not going to hurt anything. I'm just trying to get this thing dialed in, and you can save it. You can set that to what you want to. That's what that does. Then you've got your AFR maximum, where if it starts leaning out and your lambda, this all works on lambda. If your lambda goes over this lambda, it's going to cut your boost because it's getting too lean, and this is what you've got it set at. This is only going to work if you're using the wideband closed loop, because your wideband input is what this is going to use. This is your boost control enable. This is a master switch. You set that to turn on boost control. This is your boost control solenoid frequency. This can be changed. Certain Mac valves use a different frequency hertz range. You can set yours in there if you know what it's going to use, but that's what that's for. He also gives you some nice little info here on what to use. There's a 35A-AAA-DDBA-1BA. That is the Mac valve that he recommends using. It's the Mac valve that I use. It works great. I don't have to modify that frequency. It's already set up for that Mac valve. It works great. Here's your boost control base duty cycle. This is going to be where you command more boost, less boost, however you want to do it. So your wastegate, for intensive video purpose, we're going to say we have a 10-pound wastegate spring. 10 pounds is typically 170 kPa, so you're going to make 10 pounds regardless of what this table is set at. You can't turn boost down from what your wastegate spring is. If it's 10 pounds, it's 10 pounds. There's no way to get under it other than putting a lighter spring in it. So we already make 10 pounds. All of this doesn't matter. If we already make 10 pounds, and let's say we want to make 20 pounds, which would be 240 kPa. Right here is 20 pounds. You can double it depending on how you have your Mac valve set up. The way mine's set up, I can double my boost with the Mac valve. So it's going to take me 100% to hit 240 kPa. So I'm going to have to put in 100 all the way up to 240. And then just in case something happens and you're in cold weather, and it just so happens that it will make 27 or 26 pounds of boost, because sometimes the weather makes a little bit of a difference. I can hit 20, and if it's real cold outside, I can hit 22, but I don't want to hit 22. I would set this right here. We'll just go ahead and say we would set this at 100 because we want to make 20 pounds of boost. But let's say I'm at 100% injector duty cycle, and then just in case it's that real cold weather and it's going to make 2 or 3 more pounds of boost, I can taper you want to taper this down. You don't want it to hit 100, come all the way up here, and then go a little bit over it and go to 0, because then you're going to have little dips, boost spikes. So we're going to taper this down. We'll taper it down to 80, and then maybe 60 here. But you just always want to taper down from where you want your boost to go. I recommend moving this up a little bit at a time, working in, work off your gate pressure, get it dialed in on wastegate only. Then come in here and add, and I will say on my setup, 20% duty cycle is where it just starts to even work. 10, 15 isn't going to do anything. I almost go up in 20% at a time. So I would just go through here, and just for all this, let's zero this back out here. I would go through here, and let's say I'm going to start off at 40%. We're going to fill that with 40%. Fill this with 40% too. Right here, 40%. We're going to do that, kind of go out, see what type of boost it makes, but just leave your always taper it off. We'll do 30, 20, whatever you want to do here. Just kind of taper it off some. But we're always going to taper it off, but only do this up to the amount of boost that you're willing to run. If you make 10, you're making between these two right here, but I want to make a few more pounds. I'm going to run 40 a little bit above it, and then I'm going to kind of taper it off because I don't want to add a bunch of boost in at once. You can do that once you've got this figured out, once you've got your fueling dialed in. You just don't want to go straight from 8 pounds of boost to 21 unless you know your fueling's there and your timing's there. So just move in on this. Another little recommendation I got here is when you're trying to build boost at the line, you may be in this area. If you got, like I have, a 3200 stall, you can add a little bit here, 20-30%. That will kind of help you build boost when you're on the two-step or you're on the launch control. So that's how your base duty cycle is going to work. Here we have multipliers. You have a throttle position sensor multiplier. You're never going to want to command 50% duty cycle on your boost controller at 10-15% throttle. I usually just do, you can do it. This is a multiplier. You can do 2.0 and double that. You can do 1.0, which is what enables 1.0. If it's 0, it's multiplying it by 0. You're not getting anything. So 50 to 100%. I like to do 1.0 and then maybe a 0.75 here, and then 30% and below, or even a 0.5 here, and then 30% and below. I shouldn't be commanding any type of extra boost other than gate anyway. So, but that's just a multiplier there. You also have another multiplier here for flex fuel. So let's say, and this is also up to your preference, I like to do anything 50% and above. I like to do 1.0, so I get all the boost. I'll get everything that's commanded in my base duty cycle, 50% to 100% ethanol, and then right here I'll get 0.75. And then when I get to 30%, I'll do half of what I've commanded, and then below that, I'll do none of it because I'm on pump gas, and I don't want to be commanding 20 pounds of boost on 91 pump gas when I don't have the 85 in there. So that's a flex fuel multiplier. That's pretty handy for turning, having a different boost setting for when you're on pump gas or when you're on flex fuel. Pretty handy to have. Here's your overboost duty cycle cut. So you can set this to whatever kPa you want. If we want that 20 pounds, that 240 kPa, we're going to set it to 240 kPa. And if you put a number too big in that duty cycle, and it's going to make more than 20 pounds, and it comes up, hits 21, it automatically reverts your base duty cycle back to 0 to save your engine, to keep you from soaring to 30 pounds or whatever. So that's what that's for. Okay, next is going to be your closed loop fueling. This is going to be your wideband, where you're adding it in. You have your proportional and your integral. This is for calibrating that wideband in, kind of making your adjustments a little bit different. I haven't really messed with this a whole lot to give a ton of insight on it, but it probably works just like every other proportional integral controller. So you can modify those if you need to. I haven't really found a need to yet. Right here is your wideband closed loop enable. This is just a toggle, basically a toggle switch. Are you using wideband closed loop or are you not? So we're going to say yes, we are. And then here's your closed loop fueling disabled. This is a total override. You set this, closed loops disabled. I recommend doing this before you set your wideband. I know a lot of so-called tuners want to hook that Holley Terminator X up and set it on wideband closed loop and just go floor it down the track without tuning anything. And they get away with that stuff, but I don't get away with that stuff. So I just don't like doing it that way. I would rather have my VE pretty close and use the wideband to make the minor, altitude, temperature corrections for me. That's the right way to do it. So you want to tune your VE with that first, and then you can turn on your closed loop compensation. This is your wideband input ready. This is a voltage setting. There's a minimum voltage of a 0.5 volt, a maximum voltage of 4.5 volts. This setting right here, you can kind of tweak if you want to. There's probably not much need to. I use an Innovate wideband, and that works great for me. Then you have this wideband not ready delay. This is one in seconds that delays it during a transient period. I have not messed with this at all. I've left it at 0. I haven't had any issue. Maybe Brandon can chime in on a little bit more of what that table will do for you. So next, here is your wideband calibration. This calibration works for an Innovate wideband. That is exactly the settings of an Innovate wideband. I know an AEM is a little bit different. 0 volts is this lambda, 5 volts is this lambda. They have that curve available to you when you buy it, usually in the little owner's manual. If you don't have that anymore, you can probably find it on their website. But this is how you're going to calibrate the curve of your wideband. Like I said, this works great for an Innovate. No need to touch it from where it's at. Here is going to be your wideband input selection. It gives you some numbers here, 0 being the EGR position, C1 pin 55, 1 being the AC pressure, 2 oil pressure, 3 fuel tank pressure. You can set it to whatever you want to. You just have to pin your wideband into that. If there's bank 1 and bank 2, if you're going to use 2 banks, say you got a twin turbo set up and you're using 2 widebands and you want a fueling correction bank to bank, you can set one as an EGR and one as an AC, or whichever one of those you want to set it to. If you're using 2 widebands. If you're only going to be using one, you're going to set bank 1 and bank 2 to the number of where you want to pin it on your ECU. I use my EGR, so both of those would be set at 0 as they are. And I only have 1 wideband. This is your wideband input ready count. Let's say you start your vehicle and it starts up, and you've all seen it. you've got that HTR on your Innovate. It's heating the sensor up. You don't want that sensor because when it's heating up, I don't know if you've ever data logged that or not, but when it's heating up, it's usually reading a max lean reading. You don't want it just dumping a ton of fuel on your engine. So this is a timer that gives you an amount of seconds before it actually starts to look at that wideband. 25 seconds is usually pretty good. That's what I put in there. But I will say, another thing that an Innovate wideband does, I don't really need that. I do leave it set at 25 just because. Another thing that it does is the input ready right here on your voltage. It puts out 5 whole volts. So when it puts out 5 whole volts as it's heating, it never shows it's ready anyway. So I haven't needed that wideband input ready, but I do set it at 25, kind of in that just in case type of deal. But that's your closed loop fueling right there and how that functions. Next is going to be your launch control. This is probably the biggest one that I get questions on. So your launch control is also what some people would refer to as a two-step. So it works both ways on this setup here. So first off, launch control enabled. If you want to use this, you're going to set that just like the rest of them. Set the red flag. The vehicle speed max, you can set it to 0 if you just want it to let launch when you're sitting still. I set mine at 40 miles an hour because sometimes I like to hold my brake because it's brake activated. Your brake has to be activated for this to work. I hold my brake, hold my gas, and I like to do like a rolling two-step type thing. So I set it at 40 miles per hour to do that. That's up to you if you want to or not. It's awesome. I recommend it. Next is your throttle position minimum. So you got to have your brake held and your throttle position has to be over this, and that speed has to be met. It has to be lower than whatever you have your max set at for this to enable. So I set this to about 30% throttle because I'm going to be 30% or more at all times using this. I'm usually at wide open or pretty close to it. So I set this to 30% because sometimes when I'm rolling, I won't have it wide open because I don't want it to just drop and just take off. I'm just trying to build a little bit of boost. So set it at 30 is where I set it. You can set it wherever you want. And your next is your launch control engine speed soft limit. Your soft limit, I'm going to say, so I have a 3200 RPM stall converter. I like for my launch control to happen around 3100, just 100 RPM shy of that. That way it's not up on that max load of the converter, creating a ton of heat. It's just right below it, which still makes heat, but not quite as bad. So I'm going to set my hard limit at 3100 RPM. But your soft limit always needs to be anywhere from 400 to 600, maybe even 700 in some applications, lower than your hard limit. What your soft limit is, we'll put this at 2700. That's 400 lower than my hard limit. So your soft limit has a retard number here, which is always negative. We're going to pull -9. What this is going to do is it's going to progressively pull 9 degrees between 2700 RPM and 3050, which is where I had this one set at. Between those two, it's going to progressively, slowly pull out that timing before it hits 3050. When it hits 3050, it's going to cut timing and then bring it back in and cut timing and bring it back in like a two-step would and create that pop, 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 pop. You know, if these are set incorrectly, you're going to hear a really loud pop. The engine is going to stop. You're going to think something blew up, but it's going to start right back. I've done this a few times. This is kind of finicky to set up, but once you've got it, it works great. This is the settings that works for me. You may have to go down on your soft limit a few more, 100 RPM or up some more. You may have to pull more timing with the soft limit retard, maybe have to pull less. Depends on your setup, your turbo size, what you're running. This is the settings that works for me. It makes that nice two-step sound. It's just a blast, and it really helps with the launch too. I can build boost and hold an RPM. So the next part we've got here is your launch spark adder versus time. So after you have let off of your brake is what set that launch control, your brake and your throttle. After you have let off, let's say you flat foot it, you're two-step and you're holding the boost that you want. After you have let off of your brake and you start to launch, this counter counts down. And if you notice, it's in 0.1 seconds at a time, 0.1 all the way down to, I want to say it's like 5 seconds. What you can do here is right after you let off that brake, let's say it just blows the tires off. So there you can either turn down your launch limit a little bit, or if it doesn't really blow them off, like you can feel like it almost wants to hook, but you can't quite do it, you can pull some timing on the leave. So for the first half second, let's say I need to pull 4 degrees out to get it to hook up. I'll pull 4 degrees, and then I'll slowly ramp my timing back in to keep the tires planted. So let's just say you always want to do this in a ramp, like so. And once it's ramped, you're going to ramp that timing back in, and once you've got it hooked and gone, you're good to go. You can use as much of this if you want. You may not need to pull that much timing. You may not need to pull any at all. You may need to pull more timing. This is great for controlling that wheel spin. It's a little hard to dial in, but once you've got it dialed in, you can really fine-tune your combo with this. This one here is your launch control spark adder versus manifold pressure. Here to NA, I normally leave alone. Leave them at 0. I'm not going to pull anything here. Say I want to make, in this area, 125 to 145. Let's say I want to make 145 kPa max boost on my launch. I will pull timing here. I'll pull a couple degrees to get to that. And once I get to that, I will stop pulling timing, because when you pull timing, it helps, and it's different. Some setups I've noticed you add timing, which is kind of odd. Some of them you pull timing. Maybe someone more knowledgeable on this subject can chime in. But when you pull timing, it wants to build a lot more boost. It makes, I think, overall less engine power on the launch pulling timing out like this, but it makes more boost. But as soon as you let off, all that timing comes back, so then you've got boost and timing. So when you pull the timing out right here, you're pulling it out to kind of build some more boost. Then you want to, right when you hit the max of where you want to make it, you want to stop pulling that timing out, and maybe even in some cases, add a degree of timing or two here to stop that boost from building so hard. This is just a launch control spark adder versus your manifold pressure to try to control the boost, so you can hold your brake, flat foot the gas pedal, hit your two-step, and hold the boost you want, so you can get the best launch you can. This is a little harder to dial in than, say, a $3,000 aftermarket ECU is, for sure, but it can work really well if you put a little bit of time into it and do a little bit of research on this. It works pretty well for me. So that overall is your launch control. The next part is your flat foot shift. If you have a stick car, this looks to be pretty simple to set up. I don't have, mine's an auto car. I haven't got to use this on a stick car yet to know how well this works, but that's that setting if you need that. Then we move on to one of my favorite parts of the BoostOS. Actually, no, this is your limiter. So your spark limiter, if you want spark limit instead of fuel limit, you set that. Same as with the launch control. You have a soft limit and a hard limit. If you don't set a soft limit and just a hard limit, you're going to get up there and it's going to go bang and it's going to die. You're going to have to restart the truck. So this is something you're also going to have to play with if you want to use the spark cut. In my case, I don't, but it does work as I explained in the launch control. Desired air-fuel ratio. This and the spark tables are the two best additions to this entire OS, I believe. So your desired air-fuel ratio, you're going to enable it here if you want to use it, which I recommend. So we're using 4-bar. Which one you use depends on which VE table you selected in VE table selection, by the way. If you selected a 4-bar in this, it's going to use a 4-bar in all these other settings. If you selected 2-bar, it's going to use a 2-bar in all these other settings. So we selected 4. We're going to go to the 4-bar here. You have an E0 and an E80, ethanol pump gas. They work the same way. This is all based on lambda. 1.0 is a 14.6 gas scale AFR. I mentioned gas scale because most people are more familiar with gas scale AFR than lambda or other things around me. So 1.0 is a 14.6 or 14.7 gas scale AFR. These numbers would get lower to get richer. They work in lambda. It's a divisor system. You can do some research on lambda if you need to know more about that. I'll kind of show you my other file here just as a comparison what it should look like. What you're going to do is you're going to keep 14.6 AFR up until about this, and then you kind of want to taper down you know, at your 60, 70, you want to start tapering down. 100 is your max NA. Normally NA, you're going to want anywhere from a 12.5 to a 12.9 gas scale AFR on, and a gas scale on any fuel, basically on a gas scale, but 12.5 to 12.9 depending on the engine. If it's a 5.3, 6.0, high compression, low compression, you may want richer on a higher compression, a little leaner on a lower compression, and depends on how your timing and stuff's working. This will be up to you guys, but this is where you're going to set that at. Here would be 10 pounds of boost. I like to taper mine down, my air fuel down from a 12. Like say right here, I do a 12.7. I like to taper it down to an 11.7 by 10 pounds of boost, and then above that do an 11.5, and then above 20 pounds of boost, or like if 20 pounds is going to be my max, and I know it is, I'll set this down here all to like a 10.7 or a 10.8. That way, if I accidentally, by some reason, have an issue and my boost decides to skyrocket, it tries to dump a bunch of fuel rather than going lean. But this is up to you guys. This is a very nice addition right here. That's how it functions. It's all in Lambda. You also have the option to add a Gen 4 mass airflow sensor. The Gen 3 mass airflow sensor taps out at 12,000 Hertz. The Gen 4 mass airflow sensor taps out at 15,000 Hertz. You enable it right here if you want to use Gen 4 mass sensor. Then you have a calibration here. It works just like HP tuners, except it's in grams a second, which you can change your HP tuners to grams a second and copy it over to the 12,000 and then, you know, interpolate up or however you want to do that. I don't use MAF, so this table isn't really useful for me, but it could be for others. That's how you get that working. If you're not going to use MAF, however, you need to go here to the MAF disable speed density mode and set this. And that's the MAF section. And the last table we have is your spark tables. Once again, you're going to use 4-bar if you selected 4-bar in the VE table section. We used 4-bar, so you have a low octane and a high octane if you're still using NOx sensors and you still use the low octane, high octane strategy. My setup, I don't have NOx sensors any longer, so I copy these two to each other and I set the timing based off of the spark plug. That's just how I tune. You can do it however you want to, but this is your timing map. It is much better than the factory GM grams per cylinder timing map. That's my biggest hate of a GM ECU is that grams per cylinder timing map. I used to have to scale injectors to be able to control timing into boost, and it was just I'm just not the biggest fan of it. It worked. I've been pretty quick on it. It's worked pretty well for me in the past, but this is so much better. You have your timing in A, you have your timing at 10 pounds of boost, 20 pounds of boost, and everything between, all the RPM between. This is a really nice setup. I'll give you like a little peek of kind of what it looks like there, just a sample file. But that's your 4-bar spark advance. Low octane, high octane, same table. You can put more in one, less in the other. You also have a coolant table. If it's overheating and you want to pull timing out of it because it's overheating, you can. Or if it's cold outside and you want to add timing because it's real cold, you can. It just gives you the option. You have IET. This is one I actually use. 149 degrees and up. I pull timing out of it. You've just got a lot of options here, and they all work on the same axis. It's really nice. I do use the flex fuel one. I typically like to add, 4 degrees in there and leave my pump gas timing extra safe and add it in when I add in E85. That's just something I like to do because I put pump gas in. I don't plan on racing on pump gas. I don't command any duty cycle on pump gas. I don't command very much timing on pump gas. If I'm going to be really hitting this thing or going to the racetrack or doing something with it, it's going to have ethanol in it. That's just my preference. You can set this up how you want to. All that's pretty straightforward. If you guys want a better video on timing and how to do this and how to control this stuff, just let me know in the comments and we'll kind of work from there, and I can maybe try to make another one later on that. So next is your overboost spark cut safety. This is where you're going to set your max boost. If you want, if it's making too much boost and you want to cut spark, you want to set it here. You should be using the other safeties first. I don't like to just cut the spark at a lot of boost like that unless I have to. I'm going to set my boost control safety here first, a lot lower than I would set this. And if that doesn't work, then I'm going to set my spark cut. I'm going to set my spark cut 3-4 pounds above that. That way, if something crazy happens and I'm just making an absurd amount of boost, like my wastegate welded itself together, not really going to happen. But if it did, this would be my last ditch effort to save the engine. This is a boost spark adder versus manifold pressure. And if you're coming from EFI Live, this probably looks a little familiar to you. This is what everybody used to set on EFI Live. You would set your grams per cylinder timing map to max NA timing, and then you would pull. The EFI Live Custom OS had a little option like this where you could pull timing per boost from it right there, which was pretty cool. I think they had HP tuners beat timing-wise there, just my personal opinion, but you're not going to be using this anymore if you're using the map-based spark tables, and it even gives you a little note there at the bottom. It's not enabled if you're using map-based spark tables, but that's if you want to use, if you're familiar with EFI Live and you don't want to use, for some odd reason, don't want to use map-based spark tables. And here's where you would enable those map-based spark tables. All right, guys, well, that's going to conclude part 1 of my Boost OS version 5.2 how-to video, how to get set up. All you're going to want to do is, like I said, you're going to want to add your stuff in here, your fuel tank sender type, all that stuff you're going to add in. Make sure that it matches. You can compare the bin out of your vehicle. You can pull it out, compare your bin to this one. I believe you can compare a PO1 bin on this one, although I haven't done it yet. You can get on HP Tuners if you use that. Get on the VCM editor, pull out your stock file. A lot of these files are going to match up with that. You can copy and paste stuff over from that. Maybe I'll do a video later on that if some people need some help on that, but it seems pretty self-explanatory. Like, comment, subscribe, share this video. Do whatever you got to do. Have a good one.